Morning, class. Today we're going to be graphing polynomials like we've been doing the last couple days in here. I've obviously moved you to the point where you can try out a couple problems by yourself. So in this video, I'd like you to pause at certain intervals and try to graph these polynomials using the following tests. We use end behavior. We want to find the intercepts, x and y intercepts, factoring if possible. If not, you can always use quadratic formula on certain problems I'm providing you here. We want to state the possible symmetry if it's symmetric at all. State the turning points, or how many turning points there are. And then the new one today is, this is our kind of our focus in this video, is to find these max and mins, relative max and mins. Could be an absolute in certain cases, but I do want to see if we can find these in using the new test that we have. So let's move on. Let's start right away. So here's our first problem. Excuse the x squared part. So at this point, if you'd like to pause the video and try to graph this problem by yourself, I encourage that. I'll be going through the different steps of, end behavior, x-intercepts, y-intercepts, symmetry, turning points, and then finally the max and min. So if you'd like to pause, try it out right now. Okay, so if you paused and you've tried to actually take your time and try to graph this, we're going to go through the answer right now, just for the first, 4 checks that we do. So I'm going to change the color of my problem, my pen here. So what we're looking at, this is my problem. It's x squared plus 4x plus 4. Now this problem, I made it so that we can actually factor it apart. But looking at this problem, here's what we have. We have a square, so that means the tails go the same direction. It is a positive 1 out front, so it's going up. So the tails are going this direction. Again, very generic way to draw this. Now, let's try to factor this so we can figure out the x-intercepts. So 2 parentheses, it is a trinomial. We go plus plus. Now what tells me that is that they're the same symbols and they're both plus signs. That's how it works. The plus sign in the back tells me they're the same operation in these 2 parentheses at the plus sign. That's the one I circled. And now the plus sign in the front tells me that they both have to be positives. So let's go through and let's actually fill in the numbers here. So the front is x and x because we break up the x squared in the front. And then the 4 in the back, we break that up to 2 and 2, and that does make the 4 in the middle. So that means on this particular problem that we have a multiplicity. What I mean by that is that we have the same x-intercept, and it happened twice. We have x plus 2. So that means we're going to actually bounce off of this x-intercept. So my x-intercept on this particular case is a negative 2. That's the number that makes this parenthesis 0, and it happened twice. It's a double root. So that means we're going to hit negative 2, and we're going to bounce off of that x-intercept. So you'll see me do that. I'm not going to pass through it. I'm going to bounce off of it. There's no other x-intercepts other than this one. Now my y-intercept, obviously, by knowing all the different steps we've done up to this point, my y-intercept is the number in the back. That's what we've done up to this point. So this is my y-intercept. So I'm going to have positive 4. Now I think I have enough information that I can actually draw this particular graph. So from what it looks like, and now I'm not going to have the tails match up, so I'm going to erase those, but here's what we're looking at. We're looking at a parabola that goes down, touches the negative 2, comes back up, passes through 4, and goes off to positive infinity. So that's my parabola. And again, what tells me that is because it's power 2, it's going up, it's positive, so it's definitely going up in this case, but it's hitting those x-intercepts. And the multiplicity test, this little power 2, told me that it bounces off of that x-intercept. If this was an odd number, then it would pass through. So those are the different tests. Now it's not symmetric. What gives it away? It has a mixture of even and odd powers for x's. So the first one is x squared, the next one is x to the first, the last one is x to the 0. So it's a mixture of evens and odds, so it is definitely not symmetric. And what also tells me is the graph itself, it only had one x-intercept and it was not balanced across the y-axis. It has one turning point because you take your highest degree minus 1. So it turns 1 time, and you can actually see that it did that. It went down and then it changed direction 1 time. So there is my default drawing. So that's what we've done up to this point. Now, we have to get to the new part. We have to talk about what are my max and mins. Now you can actually see it on this graph, what the absolute max and absolute min was on this particular problem. In fact, I'm going to just circle it. It's pretty obvious. That's the absolute max and min. It's an absolute minimum. It's not even a relative. It's an absolute. There's no lowest point on this graph other than that one. But I want to walk you through the steps on how we do this. So this will be the first one. You're going to try the next one out by yourself, but this first one you need to see it. The test I'm going to do is, I know this is something that we've done before, it is the differential quotient. This is what we did in the last chapter test. This is that differential quotient formula. It's f of x plus h minus the original function all divided by h. That's the formula. And I'm going to use this formula in there. And so it gets tedious. That's why I said this is a very large and heavy concept that we have to try to figure out. Now, let me walk through the steps here. The first thing we have to do is take my function and plug in x plus h's into my original formula, which is this thing. So anytime there's an x, you're going to replace it with x plus h. So there you go. That is this original function with x plus h's plugged in. Now, let's walk through the next part. We have to subtract the original function off. So we're going to subtract, in parentheses, x squared plus 4x plus 4. That's the original function. And we're dividing this all by h. Now what I'm going to do is I'm going to simplify this thing down. You're going to see the steps around doing this. So this part is probably the hardest part of it all. You have to actually FOIL that out, because there is actually two parentheses there. In fact, I'm going to write them, x plus h times x plus h. We have to actually FOIL that out. Everything else that you're seeing here is pretty straightforward. I have to distribute the negative signs over everything in the back. So I'm going to do the back here. I'm going to wait on this part here for a little bit. So let's actually do the rest. I'm going to put it in a different color. So we have plus 4x plus 4h. Ooh, that was a terrible 4h. And we have the plus 4. So I'm up to this point now. Now I'm going to subtract all the rest of the stuff in the back. 4x minus 4. All over h. Now I left that part in the very front in red because I still have to FOIL that together and I want to wait. But everything else I distributed, distribute the 4 over that parenthesis, distribute the negative sign in the back. And now I'm going to I'm going to FOIL the two first parentheses. So if I FOIL first and last on these red parts here, in the back, doing all these, I get x squared plus xh plus xh plus h squared. That's FOILing that out. In the back, I still have the 4x, 4h, plus 4, and then subtracting all those other parts. All over h. Okay, so that is the entire, differential quotient. That's what we've done up to this point. And what we talked about in class is, how do you know if you're doing this correctly? Well, here's how you know. At this point, things should start to cancel. Things that do not have h's will cancel out. And you're seeing that. The 4 is canceled, the x squared is canceled, and the 4x is canceled. Because you're subtracting the original function, and so it should cancel those terms out, and those terms do not have the h's on them. So what I'm left with here is 2xh's plus an h squared plus a 4h all over h. That's what I'm left with. And yes, I know I just added the xh's together. There's two of them. Now, what I'm going to do next is I'm going to divide everything by h. So here's what I'm left with. I'm left with 2x plus 1h, because I canceled the 1, and then the 4. That's dividing everything by h. Now, I know this is a very tedious process. We've done a lot of these in the previous tests that we've done, but here's how we're going to use this. This is the new part. To go further, this formula actually gives you the max and mins. I know we already know it by looking at the graph, but this formula actually helps us find the relative max and mins on a graph when we don't know what they are, when they're going off to really high and really low numbers. So here's how we continue on with what we have here. We have the 2x plus h to the first plus 4. And I know this is going to seem odd. What we do first is you're going to get rid of any h's that are left. So if you have any h's like this term right here, those are going to go to zeros. Even if there's numbers in front of them, you'll cancel out anything that has an h on it still. So this is what we have to end with. Now, why we do that is because h represents the difference away from this, this high point or this low point. What we want to do is we want to make that absolutely 0. We want to bring this in so that there is no number that is away from that actual vertex, that highest or lowest point. So that's why we made all these h's zeros. We want to bring that distance into where it's absolute 0, and it will pinpoint right where that lowest point is. Now, with whatever's left, we set this part that has no h's anymore, we set this equal to 0. Because we want to figure out where that lowest point is, where it would dip or raise to a highest point, where basically what it is where slope would be 0. Slope is 0 at this exact moment. That's what we're doing. That's really what it's finding. It's finding slope at any point on a curve. So we set it equal to 0, and we subtract the 4 over, and divide by 2. And what that's telling us, it's telling the x number where that lowest point was. And you're seeing it. This is the lowest point on that graph. It's right where x was -2. And if you want to figure out what the actual y number is for that, you just plug the -2 back into our original function, this. And that will spit out what the lowest point is. I know that seems really odd, but it works every single time on a graph. So you take -2, plug it in here. So -2 squared plus 4 times -2 plus 4. So I'm plugging this number that we just found from my differential quotient back in. And what happens here, if I square -2, it turns out to be positive 4. 4 times -2 is -8. We add 4, and guess what? It tells me my y number is 0. So the coordinate for the lowest point was -2, 0. Well, duh, we already knew that. It was right here. But this works every single time. And it works if there's more than one high or low point. So if it's oscillating up and down, it'll find all of them. You just have to be able to factor. And this part here, whatever you're left with the differential quotient, will help us find all the x's every single time. It's awesome. It works. It's really slick, but the problem is, all of this work we're doing is really difficult. As you can see, like this took all my paper to do this. So you'll need notebook paper. We're going to try these next couple problems out by yourself, and I want to see how you can do it. Now I'm going to walk you through it, so if you'd like to pause at each separate problem, I recommend that, and then you can see me walk through it. Okay, let's go to the next one. So, if you'd like to pause right now, go through the go through the end behavior, the x-intercepts, y-intercepts, symmetry, turning points, and then try your max and min, that'd be great. So do that now. I'll wait, and then I'll start up here in a second. Okay, so if you finally came back from the paused video and you're trying this problem out now, let's walk through this. I'm going to go through this as fast as I can so you get a chance to see what the actual result is on this particular problem. Okay, so first step. End behavior. It is a power of 2, and it is a positive 2 out front, so the tails are going up, just like the last problem. It is a square graph. Now, we're going to factor this thing apart to figure out what my x-intercepts are if it's factorable. If you don't know how to factor this, you can always do quadratic formula. I'll walk you through that if you need to. But this thing is factorable. It is a trinomial. I'll try to make it such. So here's what we have. We have a 2x and a 1x. That makes the 2x squared. We have a negative. How I know that? It's a plus in the back, so they're going to be the same operation in both parentheses. They're both minus signs. And now, breaking up the 1 in the back, we have 1 and 1. And that should make the 3 in the middle. Because if you actually FOIL these out, it will make -3x. Now, the x-intercepts. There's 2, and they are separate. We set each of these equal to 0 to solve what the 2 x-intercepts are. I'm just going to cut to the chase. The first one is positive half. Again, my shortcut for doing this is always the opposite sign, and then it's the back number over the front number. That's just the rule. So on the next one, it's positive again, and it's going to be the back number over the front number. So that'd be 1 over 1, which is just 1. So I have a positive half, and I have a positive 1. So I know that wasn't the greatest look to that problem because the 2 x-intercepts are really close together. But again, these pictures don't need to be pretty, they just need to kind of work. So let's erase all these, and let's go to my y-intercept. My y-intercept is always the back number, so we're hitting positive 1 on the y-axis. And now we're starting to see where this graph is going. So it's going up, it's going down, passing through, and going like that. So the tails go up. Now, this is perfect. We have no idea where that low point is. No idea. it's below, you know, the x-axis, so it's down in the negatives. It could be a decimal for all I know, but it's below, so we have to go find it. So this is going to be some weird decimal. It's fine. My differential quotient will help me find this. So that's the beauty of this formula. It will work every single time. Now, we did the end behavior and where the tails go. We did the x-intercepts. Again, if you didn't know the x-intercepts, you could always do the quadratic formula. Negative b, so negative b plus or minus square root b squared minus 4 times a times c. Those are my numbers for my a, b, and c. This is a, this is b, and this is c. And notice the negative signs went with it, especially when I picked b, it was a negative 3. And then this is all divided by 2a, 2 times a. Now that's going to be 3 plus or minus square root, that's going to be 9 minus 8 all over 4, so this is 3 plus or minus square root of 1 all over 4, and you're starting to see what these numbers are. So this is going to end up being 3 plus 1 over 4, or it's going to be 2 minus, which is 3 minus 1 all over 4. Those are my two x-intercepts, and again, we already know these numbers. And again, how I know that? This is going to turn out to be the number 1, this is going to turn out to be 2 over 4, which is half. That's the quadratic formula. It works if you didn't know how to factor that thing apart. So again, I promised you I'd show you that. Now, y-intercepts. Oh, I already did y-intercepts, but symmetry. This thing is not symmetrical. What gives it away is that my two x-intercepts are off to the right, and again, it's a mixed bag of evens and odd powers, so that's what also gave it away. Turning points. It turned once. Well, duh, it went up and down, so it did actually change directions. Now, let's get to the main thing here. We need to get to my differential quotient. Figure out where that max and min is. Because I can see in my picture, it is there, but I have to find it. So, taking the original problem and plugging in x plus h's. H plus 1. We're going to subtract the original problem. Alright, all divided by h. So, we've got my differential quotient set up. We're going to simplify this. I'm going to do this really quick. If you want to pause the video and try to figure this out yourself, that'd be great. Do that now. Okay, so if you've paused it and you come back, so now I'm going to do this really quick, just kind of foiling this out. I'm gonna foil this together in my head and distribute the two over it at the same time. So x times x is x squared, but that's going to be 2x squared because I'm distributing the 2 in. You'll have 2x h's, but I'm going to multiply the 2 through the parentheses, so I'll have 4x h's. And then h times h, which is h squared, and then we'll take it times 2, which is 2h squared. So that's the front parenthesis, foiled out and distributed the 2 over it. I'm going to distribute the negative 3 over the next parenthesis, so it's negative 3h, or 3x and negative 3h. I have the plus 1, and now distributing the negative sign in the back, that's negative 2x squared, plus 3x, and then minus 1, all over h. Okay, so here's how you know if you did this correctly. Anything that does not have an h should go away. 2x squares are gone, 3x's are gone, and 1's are gone. So we know we did this right. Everything that's left has an h, but we need to divide everything by h. So here's what we have. We have 4xh plus 2h squared minus 3h. We're going to divide everything by h first, so we get 4x plus 2h minus 3. That's dividing everything by the 1h on the bottom. Now, like I said earlier in the last problem, what we're going to do next is if there's any h's left over, you're going to make them zeros. So that item is gone. So what we're left with is 4x minus 3. We're going to set this equal to 0, because that's what we do to check for the max and mins, and we're going to solve. We have the 3 across, and divide by 4. And there is my x where this low point is. So it's got 3/4, which is 0.75, and we need to go find the y number now. So what we're going to do is if you have a calculator, you take the 3/4 and you plug it into the original problem wherever there's x's, and that formula will spit out the y number for my lowest point. So let's go plug it in. And so we have 2 times 0.75, that's 3/4 squared, minus minus 3 times 0.75, and we'll add 1. Now again, if you have a calculator, I'm going to take my calculator out here and actually type this in, and we'll get to my final answer. And again, it'll be a decimal, it could be a fraction, it doesn't matter, as long as you know what you're getting yourself into. So 0.75, we're going to square that first, and then we're going to take that times 2. So what we have here is about 1.125. We're going to subtract 3 times 0.75, and we're going to add the 1 to it. So we should be getting roughly what the numbers coming out is negative 0.125, which, if you know, that's 1/8. But if you didn't, you could just write down the decimal, it's fine. Again, the 0.75 in the front squared is 0.5625. We take it times 2, which is 1.125. Then we subtracted 3 times 0.75, which 3 times 0.75 is 2.25, and you added 1. So there you go. Alright, again, these are finding the max and min, so that coordinate for this dot right there was this number right here. Again, it works on every single type of problem, so if you'd like to try the next one out by yourself, you can. Here's the next one. This is a quadratic function. It will still work every single time. This next problem potentially has 3 hills and valleys, but this is the problem we're going to be working on tomorrow in class. So I'd like, if you'd like to, write it down right now, and you can try this out, and then tomorrow in class we're going to walk through this to show you how we can potentially find this. Alright. Good luck. I'll have 2 problems on the board here in a minute that we're going to try together in class before you leave to see how well you pick this up, and enjoy.